Hey, welcome back everybody. So we're going to finish up talking about radical functions in this lesson. So we're on to lesson 2 in your workbook, part 2. What we're going to be doing now is taking the square root of all these different kinds of functions and see what happens when you have the square root of, say, a x squared function, or the square root of a cubic function, or linear, or whatever, right? So let's investigate that with these questions here. We are going to do a lot of this on the graphing calculator, so make sure your graphing calculator is handy. And we're going to set our window settings from -2 to 2 for x min, x max, and y min, y max. Okay, and we're going to find for each one of these examples, the square root of the function. And I'll show you how to enter that so we don't have to do as much work, okay? State the domain and range of y equals f of x and y equals the square root of f of x. Okay, so we start with, on this first one, y equals f of x equals x squared, and then, that'll be like our y1, and our y2 is going to be, and what we're going to do is we're going to actually just enter it as the square root of y1, and that way for each of these, we can just simply have the square root of y1 rather than retyping y2 every single example. Okay, so here's what we're going to do. We're going to go grab our graphing calculators, put that in, take a look at the graph of y equals x squared and the square root of that. Okay, so pause your video, grab your graphing calculator. Okay, so we should have in y1 x squared, and here's what we're going to do in y2. We're going to go square root, and then we want to bring up whatever's in y1, so that way we don't have to change it every time we do one of these examples. So to get a y1 variable showing up, we're going to vars, and then over to yvars, function, and there's our y1. Okay, so there we go, and if we hit graph, and we've set our window settings, -2 to 2 for y min, y max, hit graph, and there we go. There's what our graph looks like. So they plotted the original one here for us. We're going to graph that one, but it looks like a big V. That should seem somewhat familiar to you guys. If we have a big V, that was known as an absolute value function, right? So square root of x squared is actually the same as the absolute value of x. Okay, so that's a very important and interesting concept to know. All right, so let's do our domain of the original function f of x. Okay, so that's our parabola. Domain seems to go forever both left and right, so our domain would be L min the reals. Range, I guess I don't need to write anymore, do I? Range would be y is greater than or equal to 0, because our graph does not exist below. First point made on the graph is 0. Okay, now the domain of the square root of that. Oh, big V goes forever left and right, so again, L min the reals. And range, lowest value is 0, 0, and then it goes forever up. So same range as well. There we go. Okay, let's try the next one. How about you guys try the next one on your own, and then we'll check and see if we have the same domain and range for each one, okay? So pause your video. Let's do example I, and then check back. Pause your video, please. Okay, now did everyone remember to not retype y2, but just simply put the new function x cubed in y1, and that way it will automatically do the square root of y1. So back to graph, and we should get a graph something like this. So it looks like our new graph is somewhat curved. It was hard for me to kind of draw that here, and it doesn't appear to go left of 0 again. So even though our original domain and range for x cubed was L min the reals, our square root of x cubed, both of those were greater than or equal to 0, and for y greater than or equal to 0. Okay, we're going to start seeing a pattern after a while, but if you think about this, we were square rooting, really when we're doing square root of f of x, that's f of x is like y. So we're square rooting the y values. On our first graph, we didn't have any negative y values, so therefore our graph existed everywhere. But on this graph, we have negative y values right here. So can we square root those negative y values? No, we cannot. So therefore the graph did not continue left of 0. All right, so we'll see if that trend continues with these other ones we have to do. Go ahead and do triple I, and let's see what we get. Sketch your graph on here, come up with your domain and range, and we'll check back. Pause your video, please. Okay, so when we put x plus 1 in y1, and then in y2 it was still the square root of y1, we should have gotten this kind of graph on our calculator. So I've copied that graph onto our page here. Original function, x plus 1, that's a linear function that goes forever left and right, so element of the reals for both domain and range. Domain of our square root function, so the square root of x plus 1, you'll notice the graph did not continue past here, which kind of makes sense because everything below here, these are all y is less than 0, and you can't square root negative numbers. So graph wouldn't exist over here. Then this point, still the same. That's where we were at a y value of 1, square root of 1, still 1. Okay, so our domain would be x greater than or equal to negative 1, and y still greater than or equal to 0. Okay, you might want to think about, can we ever get a negative value for y? Because can we square root something and get a negative value? I don't think so. Okay, let's try a couple more examples, see if we start seeing, create some patterns from this. So now in y1, we're going to be putting the absolute value of x. How do we find that? When we're in y1, we're going to go then to math, num, and ABS is what we want. Or you can use second catalog, and it's the first thing on the list. Okay, so let's get that in y1. Leave your y2 alone so that we're square rooting the absolute value, and we'll see what we get. Please come up with your domain and range, and we'll check back. Okay, pause your video, please. Just to make sure that you guys got where to get absolute value from, we go to math, and then over to num, and then the first one on the list, absolute value. And then you type in x, and you end your bracket. Okay, let's look at the graph. And yeah, that does look like an open book, doesn't it? Okay, so we copy our graph here, and then we're going to talk about our domain and range. So for the original function, x was an element of the reals, okay, because it went forever left, forever right. And y, the lowest value we had for y, was 0, so it went forever up after that. For our square root function, we are basically square rooting the y values. So square root of 0 is still 0, and our graph doesn't go below 0 for below the x-axis, or negative values for y. So as a result, we again have element of the reals for x. Y, lowest value is 0, and then it continues up from there. Okay, interesting. Let's try the next one. Okay, we finished log functions now, so that shouldn't look unfamiliar to you. And if you recall, the log graph, this is hard to see on here, but it actually goes forever down and forever up, and it crosses here at x equals 1. It has an x-intercept of 1, just to refresh your memory on that. So let's see if we can come up with our domain. X would have to be greater than 0 because the y-axis is a vertical asymptote. And then it goes forever down, forever up, so our range would have to be element of the reals. Good. So why don't we now graph the square root of log x, okay, and the original function log x, and see what we get. Okay, let's pause the video and we'll check back. Go ahead and find the domain and range too on the square root of the log function. Okay, pause your video, please. Okay, when we graph that, it looks kind of funny here. So let's maybe change our square root function into like a bold line. So we go over to this spot here, hit enter, and we get a bold line. Okay, okay, now we can see where it is. Okay, so there seems to be like a little bump above that one. Okay, so let me just draw that in red, so we'd have something like this for the square root of that. Okay, so yeah, so that's all good. Let's see if we can get our domain and range then. Well, it looks like if the graph stops there at x equals 1, our domain would be x is greater than or equal to 1. And for our range, again, we're not below the x-axis, because when you square root something, you don't get a negative number. Okay, so y would be greater than or equal to 0. So you notice where the y values are negative on the original function, there is no graph for the square root of that, right? Negative y values here. No function exists for x less than 1 as a result. Okay, Last graph, let's try this one and do the domain and range for each one. Okay, so pause your video, let's do the last one. Okay, so we're kind of sitting at here for what we got with our graphing. We put negative x squared minus 1 into y1, and we've still got the square root function. It's a bold line. But when you hit graph, what do you notice? Nada, okay? So nothing graphed, or at least not on our screen, but let's think about whether we would have anything on our screen. Remember how we've been talking about how the graph doesn't exist where we have negative y values, because you can't square root a negative number? Well, this entire original function graph is negative y values. So if you try to square root negative y values, we're not going to get anything. So in other words, domain and range does not exist. And the graph does not exist, I believe. Okay, so there we go. Domain and range does not exist. Okay, let's take a look at the next page. Okay, two more examples. We're changing our domain and range on our calculator, sorry, our x and y windows on our calculator to better see the type of graph we have. Our original function right now is x squared plus 4, and we are going to graph the square root of that, and we can just again leave y1 under the square root sign for y2. All right, so let's look at our domain range first. So domain, let's see, the graph goes forever left, forever right, so it would be element of the reals. And for range, we really have no graph until we hit right here, and that's a y value of 4. How do we tell that? Take a look over here. That's a parabola that's been moved up 4. So our range would be y is greater than or equal to 4. Okay, now if we look at the domain of the square root function, let's go ahead and graph that. If you want, you can try and take a guess at what it would look like, but let's graph that and see what we get. So pause your video. Okay, so I've entered x squared plus 4 in y1. I still have the square root of that in y2, the square root of y1. I changed my window settings to match what they requested, negative 8 to 8, negative 10 to 10, and let's take a look at the graph. Oh, okay, well that's interesting. Okay, so where do you think this point right here is? It looks like 2, but why would it be 2? Let's think about that. Square root of 4 is 2, you got it. So here's our graph of the square root function. Okay, there we go. Well, it shouldn't go down to 1. Sorry, let me try and get that in a better position here. There. Okay, so that's now at 2. All right, so our domain would be still element of the reals, but our range is now y is greater than or equal to, you got it, square root of 4, which is 2. Okay, so we really took our lowest y value, square rooted it, because it's a square root function, and got our y value for our square root function, which is 2. Okay, let's try that on the next one. You guys go ahead and get the domain range of everything, graph it, pause your video, we'll check back in a minute, okay? Okay, so this is the graph we should end up with, and you'll notice that once again, notice the bold line is our square root function. There is no bold line between negative 2 and 2 for x values, because what happened? The y values went below, are below the x-axis, or our graph went below the x-axis, and our y values are negative, can't square root a negative number, so graph doesn't exist there. Okay, so our domain, therefore, has to be x is less than or equal to negative 2. It's actually, our graph is in 2 pieces, so guess what? Our domain has to be in 2 pieces as well. Or, here's the other part of the graph, or I should say and, x is also greater than or equal to 2. So less than or equal to negative 2, greater than or equal to 2 for our x values. Okay, range, y, looks like the lowest y value again is 0, and it goes forever up, so y is greater than or equal to 0. Okay, there's our domain and range. So let's kind of see what we can come up with from this. In which of these examples are the domain and the range the same, or domain's the same as the original? Okay, we're actually going to jump down to our conclusion. So, because we've been talking about this all along, the graph of y equals the square root of f of x does not exist when f of x, which is like y, is less than 0, okay, because you can't square root a negative answer, okay? If f of x is 0, the graph of f of x lies on the graph, right? Because when you square root 0, you get 0. When it's between 0 and 1, the graph of f of x lies. So if you square root like something like 1/4, you get 1/2. So it actually gets bigger, which means it lies above. Okay, let's go to part 2 to finish this up.